The first thing we did in class today was we reviewed the constant of proportionality, which is what we covered on Friday when we were working in the table with dimes and dollars. And so if you weren't here on Friday, make sure you followed that asynchronous work in Schoology before you watch this video. So on Friday, we talked about how we can represent the relationship between dimes and dollars in a table. We know that one dime, for example, is $0.25. And you could also fill out this table, of course, on your Classkick. Now, if we know that one dime is $0.25, we also know that four dimes represents $1. And we can see that in this table, we have a constant of proportionality moving from left to right in the table. So multiplying dimes times 0.25 will tell us the number of dollars. Now, that also means that for any number of dimes d, I can always multiply times 0.25. And so dollars is just 0.25 D. Because remember, when we write the letter and the number just hugging each other like that, it means multiplication. Now, also remember that if we're moving in the other direction, so if we're trying to figure out dollars to dimes, we could multiply the number of dollars we have times 4. So when we're multiplying the opposite way in the table, our constant of proportionality changes. And in this table, we have two constants of proportionality, 0.25 and 4. Now, the last thing we talked about on Friday is that 0.25 as a fraction is actually equal to 1/4. And remember that 1/4 and 4 are reciprocals, meaning that the numerator and the denominator flip, which is why they're the fractions or the constants of proportionality, I should say, for this same table. So in this final row where I put the stars, go ahead and pause this video and put any pair of dimes and dollars. Okay, so pennies and nickels, you should end up with a similar situation. You know that 1 penny is the same thing as a fraction of a nickel, right? And that 1 nickel is 5 pennies. And so if you were stuck on how to get from left to right, you could say, okay, well, I know that I'm multiplying pennies times something to get me nickels. And remember, we can use inverse operations, right? 5 times something equals 1. And that means we can take 1, which is our product, and divide it by 5. And we end up with 1/5. Right? 5 times 1/5 equals 1. And that means that to get from pennies to nickels in any direction of the table, whether it's 1 penny or p pennies, we're always multiplying times a constant of proportionality of 5. So 1/5 times p is the number of nickels, and pennies, 1 penny is just 1/5 of a nickel. So we've got two constants of proportionality. If we were moving from nickels to pennies, we would multiply nickels times 5, right? We would have a different constant of proportionality. Nickels times 5 gets us pennies. And so we have two constants of proportionality, 1/5 and of course 5. And you could put any pair of numbers in this final row of the table, right? Any number of nickels, so long as it correctly relates to the number of pennies. So pause this video and fill in this final row of the table. Remember that you can always rewind if you want to hear me explain any concept again. Okay, so the other major part of today's class was we focused on Lesson 6, Activity 2. Lesson 6.2 says concert ticket sales. A performer expects to sell 5,000 tickets for an upcoming concert. They want to make a total of 311,000 in sales from these tickets. Assuming that all the tickets have the same price, what is the price for one ticket? Well, we know that we have 5,000 tickets that we're selling, and they want to make a total of 311,000 in sales from these tickets. And so if we're looking for the price per ticket, we can simply divide the price we know divided by 5,000. And that will tell us the price for one ticket. I'm going to definitely need a calculator for that one. $62.2. And so if it's $62.20 or $62.2 per ticket, how much will they make if they sell 7,000 tickets? Well, we know that one ticket is $62.2. So what can we do to solve question 2? Go ahead and pause this video and give question 2 a try. So for question 2, you should have noticed that you have $62.2 per ticket, and we've got 7,000 tickets, and so we're multiplying. I don't really want to use the X for multiplication though. Remember, we're really using the dot, so I'm going to draw that in. 6220 times 7,000. Give me a little multiplication dot here. And 6220 times 7,000 tells us that it's going to cost $435,000 and $435,400. That's what I should say. So this artist is really making bank. Make sure I put my dollar symbol there. So notice that once I found the price per ticket, which was this part here, it became much easier for me to determine how much money they would make to sell 7,000 tickets because I could just multiply. Now, I want you to pause this video and tell me how much money they would make for 10,000, 50,000, 120,000 tickets, and go ahead and write that out here. Okay, so you should have paused the video and answered the first few parts of question 3. When we start talking about X tickets, remember that X is a variable, and a variable is just a placeholder for any number of tickets. Now we know that no matter how many tickets we have, we are multiplying X tickets times 62.20 because that's the price per ticket. 62.2 times X will always tell you the number of tickets every single time because we're multiplying the price per ticket times the number of tickets. Now, if we know that 62.20x or 62.20 times the number of tickets makes us $404,300, we can figure out how many tickets they sold because we know that 62.20 times x gets us $404,300, which means I can write a division sentence to tell me what x will be. What should I divide? Well, I know that my product is $404,300. So I'll go ahead and divide my product divided by my factor, what I'm multiplying, which is 62.20. And so I end up with $404,300 divided by 62.20. And the answer to this division sentence here will tell me what x is. And you can always check your work to make sure that whatever you get here multiplied by 62.20 is actually 404,300. And the same exact steps we used for question 4, you can use to do question 5. How many tickets will they have to sell to make $5 million? Same exact steps that we used here will help you. So go ahead and pause this video and finish this page. Come back when you're done. Okay, so you should have finished slide 2. Today's learning target was to be able to write equations using variables to represent a proportional relationship. So notice that all we did was we followed the situation to determine what are we always multiplying the number of tickets by. So for example, in question 2, we had 7,000 tickets and we were multiplying it by the price per ticket, $62.20. And x was our variable to represent number of tickets, which is how we wrote the equation. When we're multiplying something like a number of tickets times a price, this special number that we're multiplying by is the constant of proportionality in the relationship. And the reason is because if you can imagine a table, like if on one side of the table I had the number of tickets, x, and on the other side of the table I had the total cost, you would always be multiplying x times 62.20 to tell you the total cost. Now slide 3 will be independent because it's your exit ticket. I'm going to go ahead and read it aloud. If you want to get there, you can pause the video and then come back when you're ready for it to be read aloud. A bag of apples at the grocery store costs $3. Using n for number of apples and c for total cost, an equation that represents this relationship is 3n equals c. 1. What are two constants of proportionality for the relationship between number of apples and total cost? What is the relationship between these two values? And 2, write another equation that relates n and c in this context. So go ahead and complete the exit ticket, silent and independent. Ms. Kinez will email you feedback once you've got it. It's due by the end of the day. And then when you're finished, make sure you go ahead and check out tonight's homework.